Hello everyone, welcome to my channel Chemistry is Fun. Today we will be dealing with a very important element of the periodic table, hydrogen. Hydrogen is the lightest element and it is the first member of our periodic table because its atomic number is 1. It is most abundant in the universe, means its percentage is very high. Most of the stars, even our sun, consists of hydrogen. In our sun also, hydrogen is the fuel that is being used up. Hydrogen is a diatomic molecule, that is, the molecule of hydrogen is made up of two atoms. We can represent it as H2. The two atoms are linked by a covalent bond. The atomic form, that is single hydrogen atom, can exist when the temperature is very high. It is possible because the two atoms which are covalently bonded, this bond has to be broken. This bond can be broken at a very high temperature. So then we can find atomic form of hydrogen. It is a clean fuel, and since it does not produce any dangerous pollutants, it is a ideal rocket fuel as well. Now we know that we use the periodic table to make our chemistry study very systematic and easy. So first of all, we need to understand the position of hydrogen in the periodic table. See, as I told you, hydrogen is the first element because it is having a single electron in it, and also because it is having a single electron, it can exhibit dual nature. Dual nature means it can exhibit both electropositive nature as well as electronegative nature. Since hydrogen has only one electron, it can lose that electron. If it loses electrons, it forms a positive ion, H+. So this is an electropositive ion, so it is a positive ion, cation. So in this respect, it behaves like alkali metals because alkali metals also have one electron in their outermost shell, and they can easily lose that electron to form unipositive ions, as we can find in the case of lithium, sodium. Lithium can form Li+, sodium can form Na+. So it behaves like electropositive element which is having similarity to alkali metals. In the aqueous solution also we find that unipositive ions are furnished by the chlorides of both hydrogen and sodium, which is an alkali metal. HCl ionizes to give H plus and Cl minus, H plus hydrogen positive cation. Similarly, NaCl also ionizes to give Na plus and Cl minus, sodium unipositive cation. So this similarity is also exhibited in the aqueous solution. The other nature of hydrogen, namely its electronegative nature, can be seen when it gains electron. When it gains electron, its 1s orbital gets completed. 1s orbital gets completed, then it acquires the electronic configuration like helium. So now when hydrogen gains an electron, it becomes H minus. It is similar to the case of chloride. Chlorine also can gain one electron to form Cl minus anion. So here it is similar to, in this respect, in this particular characteristic feature, it exhibits like halogens. So it exhibits electronegative nature. So hydrogen can gain electron, it completes its 1s subshell. It behaves like an electronegative element just like halogens. Now we can list out the similarities of hydrogen with alkali metals. There are certain respects in which it resembles alkali metals, like in its electronic configuration. If you see, hydrogen has one electron only, so its electronic configuration can be represented as 1s1. The alkali metals are present in the first group, so The general electronic configuration of alkali metals is NS1, where N represents the main shell number, like 2s1, 1s1, 2s1, like that, 2s1, 3s1. It depends upon in which shell it is. So N represents the main shell number. Hydrogen is 1s1. Alkali metals after that, not 1, 1 is for hydrogen, 2 onwards will be alkali metals. So N represents the main shell number. And here we find that it is having only, both are having, hydrogen also, alkali metals also, only one electron in their outermost shell. So this is one similarity. Since they are having only one electron in their outermost shell, they both exhibit electropositive character, as we have seen. Both can lose one electron. We get unipositive ion in both the cases. Since they can lose one electron, they can exhibit a valency of 1. Both hydrogen and alkali metals have similar oxidation states. Like we can get the examples with electronegative elements. We find that both hydrogen and alkali metals show +1 oxidation state when they form compounds with electronegative elements. They exhibit +1 oxidation state. Both of them exhibit affinity for nonmetals. They form bonds with nonmetals, like with chlorine they can form chlorides, HCl and NaCl. With oxygen they form oxides, H2O, Na2O. With sulfur they can form sulfides, H2S, Na2S. So these are also points of similarities. Both of them are very good reducing agents because they can easily lose electrons. So since they can lose electrons easily, they are very good reducing agents. They can nicely reduce the oxides of less reactive metals like copper. So CuO is reduced by hydrogen. So CuO is reduced to copper, hydrogen oxidized to water. Similarly, CuO can also be reduced by sodium. Sodium becomes Na2O and we get metallic copper. So in both, since copper is a less reactive metal, its oxide is easily reduced by hydrogen as well as alkali metal. But everywhere we don't find friendship between them. There are some differences also with the alkali metals. Like ionization energy, if we consider, in case of hydrogen, the ionization energy is very high. It is 1312 kilojoule per mole, whereas in case of lithium, which is an alkali metal, it is only 520. So for hydrogen it is more than double if we compare with lithium. Ionization energy does not show any similarity. Hydrogen is a non-metal, whereas alkali metals, the name suggests, lithium, sodium, they all are metals. Hydrogen shows diatomic nature. Its atomicity, hydrogen is diatomic, H2, whereas alkali metals, lithium, sodium, they all are monoatomic, consists of single atom. Next we come to nature of oxides. In case of hydrogen, the oxide is neutral, H2O. Oxide of hydrogen, H2O, it's neutral. Whereas in case of alkali metal, we find that the oxides are basic in nature. We have seen Na2O, they are basic. As far as nature of compounds is considered, hydrogen can form compounds with halogens. When it forms compounds with halogens, the compounds are covalent, that is, they are formed by sharing of electrons, and their boiling point is quite low, like HCl, HBr, these are all covalent compounds, so boiling points are low. Whereas when alkali metal forms halides with the halogens, they are ionic, that is by transfer of electrons. If it is sodium chloride, sodium will lose the electron, that electron will be gained by chlorine. So two ions are produced and the electrostatic force of attraction between the two ions helps to form NaCl. So it is an ionic compound, and ionic compounds, as we all know, have high melting points. So this is a point of difference. Next, as we have seen, the hydrogen also exhibits some of the characteristics like halogens. Let us try to have a look at them. Halogens are non-metals, so is hydrogen, so it's a similarity. If we consider electronic configuration, hydrogen and halogen both have one electron less than the next nearest inert gas. For example, in case of hydrogen, the next inert gas is helium. Helium has 2 electrons, whereas hydrogen has 1, so it is 1 less than 2. Next, if you consider halogen, so fluorine, if you see, fluorine has its electronic configuration is 2,7. Its next nearest inert gas is neon. Its configuration is 2,8, atomic number is 10. So you see, in case of fluorine, there are 9 electrons, in neon there are 10 electrons. So here again, the halogen is having, like hydrogen, 1 electron less than the next nearest inert gas. And this is the reason why they can easily gain 1 electron to complete their octet. So this is the reason why they very easily exhibit electronegativity. Fluorine is highly electronegative. Next comes diatomic nature. Both hydrogen and halogens form molecules with 2 atoms, and both the atoms are joined by single covalent bond. Hydrogen H2, fluorine F2, chlorine Cl2. Next is ionization potential. The values of ionization potential is similar. If you see hydrogen and halogens, if we take the unit of electron volts, hydrogen is 13.5, fluorine is 17.4. Both exhibit electronegative character. As we have seen, hydrogen and fluorine is a halogen. Both can accept electrons easily to form anions. Hydrogen forms H-, Cl forms Cl-. So both are able to gain the electron to form negative ions. Now we consider the differences with halogens. Hydrogen is little bit less electronegative than halogens. Halogens are more electronegative, they gain electron very easily. If we see the nature of their oxides, the oxides of halogens are acidic. As you see Cl2O7, it's acidic in nature, whereas oxide of hydrogen, that is water, H2O, it is neutral. When hydrogen forms molecule, it does so by sharing the electrons. Both the atoms share 1 electron each and we get a hydrogen molecule. But here the hydrogen atom does not have any unshared pair of electron. There is no lone pair. Whereas if we consider chlorine molecule, there is a shared pair of electron. Other than that, both the chlorine atoms, each of them are having 3 lone pairs also that are unshared. These lone pairs are absent in hydrogen molecule. So this is also a point of difference. So I think you all could understand the points I discussed today.